Hello, everybody. Get stuff together here. Chat. Hello. Here is the. That's not the right link. Here is the link to the usual attendance form. Please go fill it out when you have a sec. So hopefully you guys saw the announcement that I posted or got the email that I sent that we are going to split things up, and the majority of votes were for having Whitener people meet today and Nimdari people meet on Thursday. That said, everyone is welcome every day, and although we will focus mostly on Whitener today and Nimdari on Thursday, if you're from the other class, you're welcome to ask questions. I will say, looking at the material, which I've gotten a little behind on, to be perfectly honest, I haven't kept up very well. So I'm a little bit behind on the Whitener and the Nimdari material. So you guys are going to have to kind of clue me in. But from what I could see, the very kind of broad pictures, it looked like you guys might be starting to kind of come back together, actually, as far as what you're talking about. So it might, I think what we're doing is still going to make sense, but it might be, you might still get something out of it if you're in the other class. So everyone is obviously welcome. So let me kind of throw it out there. Are there things you guys want to talk about today? I have found some more, I should say, you can certainly type things if you want in the chat. But I have found some more resources to use from a former math specialist at the Academic Assistance and Tutoring Center. So I've got some stuff I'm kind of looking through that I'm going to try and make available to you guys so that you have more resources. I think they're written pretty well. So I will do that. I just kind of have to parse through and see what makes sense to put where. But do you guys have any questions or things you want to talk about? I'll put it out there. Let me pause and give you a moment to ask a question if you have one. Population interest and sampling frame. Sure, definitely. So, and also cluster versus strata sampling, sure thing. I have to ask, the population interest doesn't ring a bell to me. So let me look. Let me just ask, not that it should be for both classes, but is that specific? Oh my God, sorry, my brain's a little tired. Is that specific phrase, or there's a word I'm looking for? Is that population? It appears in Whitener checkpoint. Okay, let me double check here because I have her stuff open. Do you know approximately what page that's on? I was reading through it. Maybe 104. Okay, let's take a look here. I'm pretty sure I had gotten that far reading through the material. Okay, yeah, sure, definitely. So let's take a look. I feel like a lot of this is going to be me talking, which is fine as far as because unfortunately, it's hard to always explain these things with good examples. So let's take a look here. Patient interest. Sorry, it might have been a little bit. Sorry, it takes a little bit of. Assume. Excuse me. I'm going to have to put a whole, so yeah, I'm not sure about population interest. Sampling frame, I'm a little bit more sure about. Sorry, 1 minute, please. Like I was going through this stuff and I remember answering those questions, and now I'm like, what does sampling frame mean? I think that's in the designing studies section here. Thanks. Yeah. Strata and cluster is definitely something I'm more familiar with. I'm gonna have to table that one, the first one you had, just because I'm not exactly sure, but I will keep looking while I talk about other things. So, as far as cluster versus strata sampling, um, I kind of think of them almost as opposites. So, cluster sampling is where you basically look at all these different groups and select some of them, and then you take all of the group. And one of the examples that was in kind of the material was about like looking at maybe all of the universities in California and then picking some of them, like 8 of them. That would be an example of cluster sampling. Like maybe you want to get a bunch of college age students, and the way you're going to select the sample is by cluster sampling 8 colleges, as is the number they used. You can use any number out of all the colleges in California. That was actually an example of a multi-stage sampling, where then after that cluster sampling, they then used strata sampling in each college. So in each college, they selected, I think, 100 males and 100 females, and the stratum there is being male or female. So the difference is kind of, I think about it as, how do I think about it? Cluster sampling, you're taking all of groups from different sections. It could be like the colleges one. It can be, if you're looking at like a state, you can pick counties from each state and pick everyone in that county. Strata, on the other hand, is you're kind of saying, I'm going to look at the whole population and divide that up into different strata. So an easy example is male versus female. An example I was thinking of for college is like, for college, you could divide the strata into, say, if you're a freshman, a sophomore, a junior, or a senior. And then once you've defined your strata, then you have a sample from each of the strata. So hopefully that kind of helps you make sense of the difference between those two. I'm trying to think of some other examples. So one kind of typical thing we think about is trying to survey voters. So, and that's kind of where I was going with the picking counties, right? If you've got a state like California, which I'm really good at drawing, look at my drawing skills. Okay, we can maybe pick my hometown, Humboldt County, and then some other county over here. I think there's like Nevada County, I don't know. And maybe we pick 3 counties. That'd be an example of cluster sampling, because we're picking all of the people in there. Or we could say, well, I don't really want, maybe those counties aren't representative of the population, so it's not a great way of doing it. Instead, we're going to say we're going to stratify by age. So we're going to group people in like ages from, say, like 18 to 27, 28 to 37, 38 to 47, and so on. Oh, sorry, 57, apologies. 58 to 67, right? And the list goes on. And so on. And then from each of those strata, we're going to select maybe 1,000 people. Randomly. Yeah. So I would say, so for cluster, you would pick everyone from the sample. I would say, I feel like cluster oftentimes, although not always, but often is the first stage in a multi-stage sampling. Um, but yeah, definitely if it was just a straight cluster, you pick everyone from the sum of the clusters, right? You're not picking all of the clusters, otherwise that'd be the entire population. But you're saying, okay, I've grouped people into these, 20 different clusters, and then I'm going to pick 3 of them. And the grouping is kind of already predefined, like you're picking the colleges or you're picking the counties. It's not something that you've done necessarily, although you could also do it other ways. For strata, you pretty much take, I would say, well, it doesn't have to be a subpopulation of the cluster. It's just you are stratifying, meaning you're grouping your population into groups in some way. Men versus women, different age groups, if they went to college or didn't go to college, if there's some kind of defining characteristic that is separating people into 2 or more groups. And then from each of those groups, you are taking a sample. So from each of these groups, we're taking 1,000 people, or from all of the males and females in California, we're taking a sample of 5,000 people, right? That's a stratified sampling system. So hopefully that kind of clarifies it. Let's see, what else? So Alia, you asked on the quiz for Whitener's class, one of the questions was about the intercept having impractical interpretation. Can you explain what that means? Yes, kind of. So I think, so I was going through her material, and unfortunately I was doing it kind of late. And so I got to the quizzes after they had closed, so I didn't get to see them. And I definitely remember looking at this. Let me go back. So this is definitely in the R stuff. Sorry, navigating to this. Yeah, sure, it should be right there. Let's see. This should be, gosh, I know I read through this. It's just hard to remember where everything is. Okay, so the question is definitely false. The intercept always has a practical interpretation, but I'm trying to kind of get to a, I know there was something I read and I'd like to kind of see that. So yeah, all right, cool. So this is definitely, this question is in the context of like doing a scatter plot and then doing regression analysis to finding the best fit line. And if we look there, so here's one of the examples from the reading. So one of the examples was where the explanatory variable was age, and the response variable was the distance at which someone could read a highway sign, right? So I'm not going to obviously reproduce the data exactly, but it looked something like this. So you had the explanatory variable here on the x-axis, and the distance that they could read something at on the y-axis. And the data, not surprisingly, showed that at a younger age, you could see things at a further distance. And then as you went this way, as your age increased, you could see things not as, right, you could only see things up to a lesser distance. Now, in this case, the y-intercept, which I believe the question is about the y-intercept. Let me double check. So the y-intercept here would mean the age was 0, which doesn't have a practical interpretation, right? It doesn't make sense that a 0-year-old person would, one, be looking at, right? I mean, you could have someone who is 0 years old, right? They're just born, but in the context of this thing, we're looking at people who are 18 years older. So there's no practical interpretation because we didn't survey anyone of that age. So that's kind of what that means. You could also say that, I guess, if you wanted to go the other way, so in general, I believe that question is always about the y-intercept, which is the, oh gosh, how do they write it? I think they write it as y equal to, it's kind of a bummer. They use b for the slope, and we're just using b for the y-intercept. Right, they write it as like y equals a plus bx. So we're setting x equal to 0 and saying, does it make sense that y equals a when x equals 0? And not really, not in this case. It does sometimes, but not here. You can also ask about the x-intercept, which I don't think is what the question is asking about. But if it was, you're saying, okay, does it make sense there's an age at which you can see 0 feet, a sign 0 feet away? And the answer is probably no, right? That also doesn't make a lot of sense because everyone can probably see a sign at some distance unless they are actually blind. But if they're actually blind, they probably wouldn't be driving, so they wouldn't be in the survey. So I think this is an example where neither of the intercepts really have a practical interpretation. Good questions, you guys. I think I definitely need you guys to ask questions because it's hard for me just to be like, okay, we should talk about this. And I'm still trying to kind of figure out an answer to that other question. I don't remember where the sampling frame stuff was. Let me take a look here. Relationships. This is unit 3, I think. Yeah, okay. I think I'm almost there. Let's see here. No, it's really fun just to watch me look at my computer. Okay. Okay, come on. Hello. Well, also, here's the link to the attendance again. I did also, just so you guys know, I posted a quiz. It's available, I think, until like, I mean, you can really do it anytime, but you can try to do it by tonight or tomorrow night. Also, if you have other things going on that are more important than the quiz, that is fine. Yeah. Don't you hate it when you know you found something before and you can't find it again? I know I do. You know what? Instead of trying to read through this, I could literally just Google the thing and try and read right there. Yeah, so let's see. Let's see what that pulls up. Okay, so here's what I, just by Googling, I see that a sampling frame is a list of all the items in your population. It's a complete list of everyone or everything you want to study. The difference between a population and a sampling frame is that the population is general and the frame is specific. Okay. So reading some more here, qualities of a good sampling frame. You can't just use any list. Care must be taken to make sure your sampling frame is adequate for your needs. For example, according to Alaska University, a good sample frame for a project on living conditions would include all individuals in the target population, exclude all individuals not in the target population, and includes accurate information that can be used to contact selected individuals. Okay. I still don't think that really answers your question about what population interest is. Yeah, I wish I had a better answer. Also, I spelled frame wrong. Okay, I see. So a sampling frame, I think I have an answer to your question. A sampling frame is a list, is a list of things you draw a sample from. So it might not be the entire population, but it would be some subset of our population. So you kind of go through the entire population and then the sampling frame that you want to take a sample from, and then the sample that you actually take. So let's take a look here. Yeah. So does that kind of clarify things for you? Okay, well, that's good. What else you guys got? Not that I'm saying that like I am really the expert here, meaning more like that wasn't a challenge. It was a do you have any genuine questions? And anyone can ask a question, even if you're not in Whitener's class, right? It is open to everybody, but the focus is meant to be for Whitener. But we're happy to look at everyone. Okay, notice it says the sampling frame that should match the population of interest. I can be looking at her notes. Yeah, I forgot I have her notes over here too. Let's see here. There's so many things to look at. How are you guys feeling? I feel like there's a lot of like, I feel like if I were a student right now, I would feel inundated with information. Let's see. So looking at her, not that you have to tell me how you're feeling, but I was just pointing out, I would feel like I will never take an online class again. I totally get that. So in that vein, I would remind you guys that, so we don't know what fall is going to look like yet, but it's certainly possible that fall might be online as well. And so if you're thinking you might not want to take online classes in fall, which I totally understand, I would not want to take online classes either if I didn't have to. There is the option to PELP for a quarter. So if that's something you're interested in, I would definitely encourage you to take advantage of it. Let's see. Yeah, so I'm looking at her notes and exactly what you said, Adeline. The sampling frame is the list of individuals to be studied, and it should match the population of interest as closely as possible. So yeah, and her example is like the UC Davis population. I'll answer that question. Yeah, the sampling frame should match the population of interest as closely as possible. So if our population was UC Davis and we were trying to take a sample that was representative of the entire UC Davis population, we have to be kind of careful how we sample. And so we're talking about trying not to be biased. If you just took a sample of people from a class, you're certainly kind of having some sort of, that might not be representative of everybody. So yeah, you're definitely correct. The sampling frame should match the population of interest as closely as possible. Someone did ask me a private question. There is a limit to how many times you can PELP. You are only allowed to PELP one quarter, I believe. I think I sent you all an email about PELPing at the very beginning of the quarter, but I can definitely post that information in Canvas again if you want to know about it. Also, I'll do a little bit more research because I think they might have done some updating of their PELP information just to make sure, because I know there were a lot of students who were doing that last quarter or interested in doing it for this quarter. So I'll take a look. I will make that available to you, but I'm pretty sure you can only PELP one quarter. The exception being, which was actually my exception, I PELPed for a whole year before I came to UC Davis because I ended up living in France for a year. So yeah, you can PELP for one quarter if it's not before you start UC Davis. Other questions, either about stats or about other things? Yeah, I will say, if you guys, so just as a follow-up to the questions you guys have asked today about sampling stuff, her, if you look at her lecture 8 PDF notes, I feel like they do a pretty good job of kind of getting the point across about convenience or about all this kind of stratified sampling versus cluster sampling. There's some nice pictures there. Also, if you look at the, gosh, where was I? I know the OLI stuff, which I don't remember what that stands for exactly. There was definitely stuff about stratified versus cluster sampling, and I'm trying to remember what page that was on. I definitely feel like I think it's in the designing study section, which is module 7. If you look at, I feel like her page, and I know this is kind of older material for her, right? Like the quiz for this section has already ended. I think I'm going too far here. I can't remember where I read the thing that I want to tell you guys about. Okay, maybe it's not unit 3, maybe it's unit 2. Take a look. No, unit 2 is all that. That's all. There it is. It's the second half of unit 2. It's the examining relationship stuff, I believe. If you look at all the role classification stuff. Yeah. I know that they use these, so there were like 8 examples on page 47 where they talk about the relationship and the explanatory and the response variable being either qualitative or categorical. I think are the words they use there, C and Q, sorry, quantitative or categorical. But then later on, I know that they also kind of use those same examples to talk about clusters and strata. I don't remember where. Of course I remember where. Maybe I found it. Nope. Also, so I know someone had asked before, gosh, I wrote this down. Let's see here, one quick second. Someone had asked me a question that was really good, and I don't have an answer for it. But I didn't want to say like, or I didn't want to pretend like I just forgotten about it. I definitely didn't forget. Where did that question go? Yeah, someone asked, where are you? Is the reason why the OLI course does not examine a quantitative variable being the explanatory variable and a categorical variable being the response variable because of the principle that association does not imply causation. And to be honest, I don't know. It's a possibility. I think maybe just because it's hard to do. But yeah, I'm looking at the page here where they're like, we're not going to look at this one. And they don't even want to talk about why. So this is page 71 of the OLI book. We've now, it says, like I'm reading the paragraph, we have now completed learning how to explore the relationship in cases where C is the explanatory and Q is the response, or C is the explanatory and C is the response, or Q is the explanatory and Q is the response. And then as noted before, Q is the explanatory and C is the response will not be discussed. And that's all they say, which is kind of lame. But and I guess the bright side is we don't have to worry about it really. But I do think that's a good question to ask. I wish I had a better answer. I definitely did some Googling around to see if there were any like reasonable answers. And I was not able to find anything that made it kind of clear why that wouldn't be something we would explore. It's a question you could ask your teacher. I imagine if it's White, I feel like I've got a better read on White, like I've seen her teach and I've emailed with her. She seems like she would be certainly willing to answer questions if she is your teacher. So I would say ask her if that's your question. She might have an answer for you. She might not. I'm still trying to find that thing I really wanted to find. Also, I will be trying to post a new poll if you guys want to do the poll. I feel like the poll should just be fun, like the one last week was. I'm gonna try and make it so you can actually like. I feel like I still don't understand how the polls work in Canvas, to be honest. Like there's so many different ways to do them, and the second week didn't work very well at all. Let's see. I think I found the thing I was looking for. So page 83 of the OLI textbook has some good questions about clusters versus stratified sampling. And I definitely think answering the "did I get this" questions is a good way to kind of assess whether I mean, they literally, right, did I get this? That's what they're good for. They definitely make me feel like I'm getting it when I answer them correctly. So I would say look at those and try to kind of do that. And if we look at the next page here, there's just, I like there's a lot. So I should also ask for whiteness toss. I assume you guys have started talking about probability stuff because I definitely see that in her more current notes, right? Like if we look at the, let's see, and I think her lecture 9 stuff, yeah, she definitely started talking about probability in lecture 9. And I assume she also talked about it in lecture 10. Let me take a look here. Yeah, okay. And that's definitely, so the questions I asked on the quiz are more about that kind of stuff. Can you talk about theoretical versus empirical probabilities? For sure. So I'm going to take a look at those pages. Although I'm pretty sure I have an idea of what that means. I should double check. I can't process my request. I typed in the page number and it was like, no. 1 second here. Let's try that again. Why can't I just go to the page I want to go to? Okay, there we go. So there are two fundamental ways in which we can determine probability: theoretical, also known as classical, and empirical, also known as observational. Okay, so classical methods or theoretical methods are basically just, how do I say? Well, I mean, so they say it right here. Classical methods are used for games of chance, such as flipping coins, rolling dice, spinning spinners. So basically things where the probability should always be an exact, precise number. For example, flipping a coin, we expect, and we actually use the word expect for a reason, right? There's something called the expected value, which is literally the same as the average, right? And we use, right, expected value is a term that also means the mean. If you're flipping a coin, we expect to get a heads half the time and a tails half the time. Now, empirically, if we actually flip the coin 1,000 times, we're not going to get exactly 500 heads and exactly 500 tails. I mean, you might, it's possible, but we're probably going to get something more like, 537 heads and 463 tails. So the probability, I mean, I don't know exactly what the probability of that is, although we could figure it out. But the idea here is that theoretical values are going to be exactly precise. They're going to be exactly the probability you expect things to be. Whereas empirical values are going, or the observational values, empirical values are going to be not always exactly what you think they're going to be. They're going to be close if it's something that we know how to calculate the probability of, but it's not going to be exact. On the other hand, there are things where we wouldn't have an exact probability. Like if you're just, and I'm struggling to come up with an example in my head. So are there any examples here? Let me take a look. Just 1 minute. Sure. So they go on to the example of blood type. Like what's the probability that someone's blood type is A? And while we may know approximately what the probability of blood type is by knowing from the population, right? Like we could take a sample size of, I don't know, I mean, I'm sure lots of people's blood types are recorded for various reasons. So we could take a sample from like all of California by looking at maybe all the medical records of all people. It's probably not against, it's probably against some HIPAA rules or whatever, but let's pretend like we knew all the blood types of all the people in California. And we knew that 20% of people had type A blood. That would probably be a pretty good representation of the, at least the United States in general, maybe. And so we could say, if I selected someone at random, it's probably not a bad guess that the probability that their blood type is type A is 20%. But that's not an exact value, right? That's an empirical value that we've derived from evidence. Whereas the probability that you roll a 6 when you're rolling a 6-sided die is always going to be 1 out of 6. Not because we've observed some data of rolling dice over and over again. It's really because of the physical properties of this shape, right? We expect that a fair die is going to roll a 6 1/6 of the time because of the evenness and the symmetry of the shape. And so when it's something like that, we just say, oh, it's nice and perfect, it's 1/6. Whereas it's something like where you're looking at a population and you don't actually know the probability of having a blood type, for example, because it's not something that would just be 1/4, 1/4, 1/4, 1/4, or whatever it is. That's the difference. And I think I've helped make that make more sense and not more confusing. Here's the attendance form one more time. But yeah, that's a good question, Shelby. I like that question. I mean, I like all your guys' questions. You guys are asking good questions. So what else? Are there other probability questions you guys have? Sorry, I just sent the. So I always make the mistake of when someone sends me a private chat message, then I try to respond to everyone, but I have to click on everyone. So here is the link to the attendance form one more time. And I got to write down to remember to do stuff. Also, as a reminder to everybody, just so you know, you can change any of your classes to pass, no pass up until the last day of instruction, which I believe is June something, June 4th maybe, or 6th, I don't know. Let's take a look at the calendar. June 5th, I believe, is the last day you can change the pass, no pass. So if you're gonna get a grade in this class that is not gonna help out your GPA, so that's a good question, Shelby. Does that include major classes? And the answer is you probably need to talk to your major advisor. Different colleges have different requirements about how many of your classes you can take pass, no pass towards your major. And I think, I don't know this for sure, but I think there's been some kind of movement in their perception that maybe they should, you know, make some exceptions this quarter. But yeah, definitely, if you know your major has requirements about how many units you're allowed to take pass, no pass, or what kinds of units you should take. Like maybe it's fine if you take your GEs pass, no pass, but actual classes for your major are supposed to be taken for a grade, then yes, you should talk to your major advisor. Oh, okay, that's fine. Yeah, sorry. As people, so yeah. Anyway, so what else about probability? Sorry, I'm just talking to myself here, and also to you guys. I'm not just talking to myself. So the probability stuff is actually the stuff that I'm hopefully better at explaining. It's the stuff that makes more sense to me. And a couple things that really kind of come up often in this class are things like conditional probability, events being mutually exclusive, what's that I'm looking for? Events being independent. So those are kind of things that we should talk about at some point. But I just want, so the thing I want to make sure everyone is super clear on is independence. Because I feel like that's, of all the things that people struggle with, that is one of the ones that people struggle with the most. So, and actually, let me see. I know I have some examples here. So let me just give me 1 minute here. I think that's the file I want. No, you're not the file I want. You're the file I want. I found a bunch of files that have great questions, but I haven't had time to go through them all. So I'm like, I think it's you, but maybe it's you. Sure. So dice are often easy to talk about with probability. So let's say we have a fair die, and unless someone says something, otherwise you should assume your die is 6-sided. right? There are, of course, other shapes for dice, but the six-sided die is the standard, typical shape. So a fair die is tossed 2 times. Well, let's say we have these 2 events. A is the event. That's interesting. If we grabbed a different question, not sure. A is the event that the product of the 2 rolls is greater than 8. And B is the event that the second toss is a, let's say a 2. So first of all, what are the probabilities of each of these things? So let's find the probability of B, which is easy. So what's the probability of the second die is a 2, or the second toss is a 2? Well, second toss doesn't care what happened on the first toss. Right? I rolled the die 1 time, I got something. I rolled the die the second time. What's the probability that the second roll is a 2? It's 1 out of 6. We could make the whole list of all 36 possibilities, which we might have to do to answer the first question, actually. And if we did, right, if we made the whole list of 36 possibilities, which I'm not going to do just yet, where the first die, right, is down here. It could be a 1, a 2, a 3, a 4, a 5, or a 6. And the second die is over here, and it's a 1, a 2, a 3, a 4, 5, or a 6. And there's exactly 6 ways. Sorry, my writing looks terrible there. There's exactly 6 ways where the second die is a 2 and the first die is something. 6 out of the total 36 is 1 6. And we didn't need to do all that to figure that out, right? We could just say, well, the first die can be anything, and then the second die, there's a 1 in 6 chance of it being a 2. Now, to answer the first question, I think requires a little bit more work. So the event that the product of the 2 rolls is greater than 8. I feel like it might be easier to think about the complement, actually. So instead of finding the probability of A, it might be easier to find the probability of A complement. So if A is the event that the product of the 2 rolls is greater than 8, the complement, so A complement, I should say, is the event that the product is less than or equal to 8. Right, so since this is kind of a discrete variable where you just get integer results, if you want to separate an integer, one side has to be strictly greater than, one side has to be less than or equal to, or one side is strictly less than, the other side is greater than or equal to. So I want to think of all the ways I can have a product that's less than or equal to 8. Well, certainly I can have 1 for either die, and that'll work out right. So I'm just kind of list all the things that make sense. So if I have the first and the second die, I can have a 1 for either one. Right? I have a 1 and a 1, or 2, or 3, or 4, or 5, or 6. And then I could have the first die be a 2. The second die could be a 1, or a 2, or a 3, or a 4. Right? That'll still be less than or equal to 8. The product, right? Not the sum, the product. And then if the next die is a 3, the first die is a 3, I can have a 1 or a 2, but I can't have a 3 because 3 times 3 is 9. I got a 4 here and a 1 or a 2 there. And then I could have, I'm running out of room, I could have a 5 and a 1, but not a 5 and a 2, or a 5 or a 6 and a 1. And again, I want to point out, right? Sorry, actually, I'm going to I'm gonna erase here. Sorry, I know it's terrible, but I want to make this like this. Right? I haven't repeated any counting, right? Because I can have the first die be a 1 and the second die be a 6, or I can have the first die be a 6 and the second die be a 1. Those are different events. Or I should say the first toss is a 6, 1, and the second toss is a 6, or the first toss is a 6 and the second toss is a 1. And those are distinct things that can happen. So let's see, how many ways are there that right, this is the less than or equal to 8. This is the greater than 8. How many ways can I get it to be less than or equal to 8? Well, let's see, there's 1, 2, 3, 4. There's 6 plus 4 plus 2 plus 2 plus 1 plus 1. So that's going to add up to 10, 12, 14, 15, 16. So there are 16 ways of getting it less than or equal to 8 out of 36 total possible ways we can toss 2 dice. And we can reduce that fraction to what? 4 out of 9. So the probability of a complement that the product of the 2 tosses is less than or equal to 8 is 4/9. That means that the product of A, that the product of the 2 tosses is greater than 8, would be 1 minus that, which is 1 minus 4/9, which is 5/9. So that would be the probability that our 2 dice have our 2 tosses have a product that is greater than 8. Now, the question I really want to ask is, are these events independent? Yeah, I think we can fit this in over here. So are these events independent? Meaning, if you know one of them happens, does it affect the probability of the other one happening? So I want to ask, is the probability of A given B equal to the probability of A? If those are equal, that means the events are independent, because knowing B didn't affect the probability of A. If they're not equal, then they're dependent. So let's take a look. What's the problem? Well, we know the probability of A, right? This over here we just found was something, 5/9. Okay. Now, what's the probability of A given B? Well, B is the event, the second toss is a 2. So we can definitely circle all those. Let's see. So here's where the second toss is a 2. Here's where the second toss is a 2. Second toss is a 2. Second toss is a 2. So out of the, sorry, I think for this one in here. So the probability of A given B. Oh, sorry, my brain just lost it for something. Yes. Okay. So, and this is the probability of A intersect B divided by the probability of B. The probability of B was 1/6. I know we're almost out of time. The probability of A intersect B is, well, you have to have A and B happen. So how many ways you can get A and B? Well, so that's where the second toss is 2, and the product is less than or equal to 8. Sorry. I feel like I made a small mistake here. I made my list. I mean, it's not a mistake so much as sorry. Let me. I want my list to be all the other things. So let's ask this question instead. I'm going to change the question just a little bit. Sorry. Are A complement and B independent? Sorry about that. This question will be easier to answer with what we've already written on the thing. So A complement was, I know I've lost my things here. So A complement was being less than or equal to 8. And so the probability of A complement was 4/9. The probability that the product is less than or equal to 8, given that the second die is a 2. Let's see, so that's going to be the probability of A complement and B divided by the probability of B. And that's going to equal, so again, the probability of B, the second toss is a 2, is just 1/6. The probability of A complement intersect B is that you have the second die being a 2 and the product being less than or equal to 8, which is all of the red ones I've circled here, right? You can have a 1 and a 2, or a 2 and a 2, or a 3 and a 2, or 4 and a 2. There's 4 of those out of 36 possible. So you end up getting 4 out of 36 times 6 over 1, which is 4 out of 6, which is 2/3. So these probabilities aren't the same, which means these events are dependent. Sorry, I got a little mixed up there. One thing I want to point out is, although I calculated this probability this way, the way I was really thinking about it was I was saying the probability of A complement given B, given that the second die toss was a 2, well, there's 6 ways that can happen, right? It can be 1/2, or 2/2, or 3/2, or 4/2, or 5/2, or 6/2. There are exactly 4 out of 6 of those ways. 4 out of 6 of those ways that we can have the product of the 2 dice being less than or equal to 8. So you can also do it that way, which I think is a little bit easier. But the point here that I want to make absolutely 100% clear is that these events are dependent. And knowing that the second die toss was a 2 affects the probability that the total of the dice is, or the product of the dice is less than or equal to 8. We'll definitely talk more about this in the future, because independence is something that we kind of talk about, I think, a lot personally. But just make sure you're cool with this, right? If you're checking for independence, you're checking if the probability of A given B is equal to the probability of A. If the answer is yes, the events are independent. If the answer is no, the events are dependent. All right, I'm gonna end it there. Sorry, it's a little, I know it's a little over time. Do make sure you fill out the attendance form. I will be sure to post the information about Pelping again in case anyone's interested. And please feel free to ask me questions via email or in the discussion on Canvas. And I will just say in general, the more questions you ask me, the better I'm able to help you guys. You're definitely, yes, you can certainly, so I will say you're welcome to attend both sections for the participation points. I would also say don't sweat the participation points. I'm probably gonna, I will figure out how to modify them so that if you only attend one class a week, it's fine. My intention is that you all pass this class. So I will modify it. If you don't want to attend the other one, you certainly don't have to, but you are also very welcome to attend both. So I will see you or not on Thursday, and then I will see you on Tuesday for sure, if not on Thursday. All right, I got to go eat lunch with my wife. Take care, and I will see you all later.